Number 1 gives us some special right triangles, and we want to use our special right triangle formulas or parent triangles with proportions to solve for x. So first I'm just going to draw out our 2 parent triangles in the bottom here that these are similar to. So for the 45, 45, 90, where we've got an isosceles right triangle, where these angles right here are 45, remember that all of these triangles are similar to a triangle that has legs of 1, 1, and a hypotenuse of square root 2. Then for our 30, 60, 90 triangle, so we have a right triangle. We have our smaller angle being 30 degrees, our larger angle being 60 degrees. Across from the 30-degree angle has a side length of 1. Across from the 60 has a side length of square root 3. And then the hypotenuse is 2. So every 30, 60, 90 triangle is going to be similar to this parent triangle. You may also have formulas, and the formulas that you've looked at. So let me move these around here. The formulas or connections that you've made here in the 45, 45, 90 are that the hypotenuse equals the square root of 2 times the leg. So whatever the leg is, we multiply by square root 2 to get the hypotenuse, okay, or backwards you could divide by 2. In the 30, 60, 90, you have that the hypotenuse is always 2 times the shorter leg. So you can see that here, the short leg is 1, multiply it by 2, you get the hypotenuse, or backwards would be divide by 2. Then the longer leg, so let's just, long leg here. So the long leg is always equal to the square root of 3 times the short leg. So you can also do it that way, where if you have the short leg, you can multiply it by the square root of 3 to get the long, or divide by square root of 3 to go back to the short. So in this first one, we see that we are given the short leg here of a 30, 60, 90. And so then you can kind of use those proportions here to get this longer leg. So remember that the longer leg is always the square root of 3 times bigger than the short leg. So we should be able to take this 9, multiply it by the square root of 3, and get the longer leg. So that longer leg is going to be 9 square root 3, or you could do that as a decimal. If you're doing proportions, then you could match up this short leg to the short leg here. So I like to go like this and just put a 1 under the short leg, and under the long leg goes the square root of 3. So then you would have a proportion to set up here of 9 over 1 equals x over the square root of 3. And then you'd be cross multiplying. So you'd get that 9 square root of 3 equals x that way as well, if you like doing proportions. For this next one, we see that it's a 45, 45, 90. So we've got the leg here. Okay, so we've got one of the legs, and then we want to find the hypotenuse. Remember that the hypotenuse is just a factor of square root 3 times, or square root 2 times bigger. Whoops. So we go from 1, we'd multiply by square root 2 to get the hypotenuse. So in this case, we would multiply 9 by square root 2 to get the hypotenuse. So we would have 9 times the square root of 2, or you could do the decimal version here. If you were doing proportions, the 9 goes with the leg, so that's similar to this 1. The hypotenuse goes with the square root of 2. So then you have 9 over 1 equals x over square root 2. And then you'd have that cross multiplication to end up with 9 square root 2 that way as well. This third one is equilateral. So equilateral means that we know that this large angle here is 60. So then if this is 90, then this little angle in here would be 30. So we have two 30, 60, 90 triangles, and we're given the hypotenuse. So we have the hypotenuse here. So remember that matches with this 2 in the parent triangle. And then we're looking for the long leg, or we're looking for the one across from the 60-degree angle. So we're looking for this one. So if you are doing kind of the formulas here, you're going to need to go from 3 to find the short leg to then go to the long. So if this is 3, then this is half of 3, or 1.5, just 1.5. Okay, so half of 3, so 2 divided by 2 gives us that short leg. So in this case, it'd be 3 divided by 2. Then we would take and multiply by square root 3 to get that long leg. So you'd have 1.5 times the square root of 3. You can also do proportions. Okay, so the 3 is the hypotenuse, so that matches with this 2. And then the x is the long leg, so that's matching with this square root 3. So then we would have 3 over 2 equals x over square root 3. Cross multiply, and you'd get 3 square root 3 over 2. And 3 over 2 is 1/2. So this is the same thing as this. Number 2, now we need to use those formulas to find the area of the triangle. Remember that area formula for a triangle is base times height divided by 2. So we need the base, we need the height, we need to multiply those, and then divide by 2. So these are equilateral triangles, meaning that they're split into two 30, 60, 90s, right? Because we've got all these angles, all these big angles are the same, so they're 60. So then this 60-degree angle split into 2 is 30. So then we'll be able to use our 30, 60, 90 formulas. So this is the long leg. So then the short leg is just the long divided by the square root of 3. So this short leg here is 5 to this part. So 5 and 5 here, giving us our base of our triangle as 10. So then plugging into the area formula, you're going to do base times height divided by 2. So our base of this triangle is 10 times our height, which they gave us as 5 square root 3, and then we're going to divide by 2. So then this would be 50 square root 3 divided by 2, and 50 divided by 2 is 25. So our area would be 25 square root 3 units squared, and you could certainly do the decimal version there as well. This next one, again, two 30, 60, 90 triangles. Okay, so you've got that 60-degree angle here. We're given the hypotenuse in this case. Okay, so all of these sides are 14. Okay, this is half of one of those sides, right? So half of the hypotenuse is 7. And then the height would be that times the square root of 3. Okay, so then this is 7 square root 3, matching up with those 30, 60, 90 formulas or parent triangles. 1 square root 3, 2, right? So then take the hypotenuse divided by 2 gets us to the short leg, and then the short leg times the square root of 3 gets us to that longer leg. So now we'd be able to take the base, okay, which is 7 and 7, so the base is 14, times that height. So we're doing 14 times 7 square root 3, and then dividing by 2 to find the area of our triangle. So 7 times 14 is 98. So we have 98 square root 3 on the top there, divided by 2. 98 divided by 2 is 49. So 49 square root 3 units squared for the area of that triangle. Number 3, an airplane travels 125 miles horizontally during a decrease of 9 miles vertically. So they're giving us, this horizontal distance that the plane traveled is 125. versus the vertical distance it traveled is 9. Write an equation using inverse trig that would help you find the value of the descent angle. So the angle of descent is this angle here. So to find this. So in order to do this, we need to be labeling the sides as opposite, adjacent, and hypotenuse. So across from this angle is the opposite side. Next to it is the adjacent side because this one's the hypotenuse. So you've got some different functions here, okay? So the acronym to remember these is SO, CA, TOA. You also have them written on your reference chart. So we have the O and the A. So that's going to be connecting with the T. So that's the tangent function. So remember, tangent function is equal to the opposite over the adjacent. So here we actually need to solve for the angle. So we're going to be doing the inverse function. So theta, the angle, is going to equal the tan inverse of the opposite side, 9, over the adjacent side, 125. So when you're looking for an angle, remember that's the inverse tan. Now use your equation to solve for the value of the variable. So you'll type this into your calculator. So you'll do the inverse tan of 9 divided by 125, making sure that your calculator is in degree mode. And you should get, and it wants to the nearest degree. So this was like 4.11. So to the nearest degree, that's 4 degrees. Number 4, Claire is flying a kite. She gets tired, so she stakes the kite to the ground. The kite is on a 30-foot string. Okay, so this string that the kite is on is 30 feet. It makes a 27-degree angle with the ground. So we see that this angle here is 27. And then we want to figure out how high the kite is off the ground. So whoops. So we want to figure out the height of this kite. So again, we're given a right triangle with an angle and one side length. So we'll be able to do trig here. So we want to label the sides based on the angle. So the angle is what's important. Okay. The hypotenuse is always across from the 90-degree angle. So this is the hypotenuse. And then X is the opposite side. So remember, you've kind of got this acronym if you want, or you should have this on your reference chart. But we've got SO, CA, TOA. In this case, we have the H and the O side. So the H and the O side is right here. That's with our sine function. So then remember that sine of theta equals the opposite over the hypotenuse. And theta is the angle. So we'll do sine of, and in this case, the angle is 27. So the sine of 27 equals the opposite side, which is X, over the hypotenuse, which is 30. So then type in sine of 27 in your calculator, and you should get 0.4539. I like to do at least 4 decimal places. That equals X over 30. So now you can just turn this into a proportion if you want to think about it that way. And then you're cross multiplying. So you're going to do 30 times this. Okay, so multiply that 0.4539 times 30. And you get 13.617. And then 1 times X is just X. Now this one wanted us to go to the nearest tenth of a foot. So that's 1 decimal place. So 13.6 feet for this one. Number 5, given these 2 triangles below, answer the following questions. So how do we know that these triangles are similar? Side, 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 angle, or angle, angle. Now, they don't give us any measurements for the sides. They just have letters. So we have no way of knowing if the sides are proportional just by looking at what R over B is, because we don't have any numbers there, or P over C. But we do see that they gave us angles. They said this angle is beta and so is this one, same variable. They gave us this one is alpha and this one is alpha. And they gave us 90 and 90. So all of the angles in these triangles are the same. So that means that these two triangles are similar by angle-angle similarity. And then what do we know that alpha plus beta is? Well, if this is a 90-degree angle, remember that a triangle totals 180. So if we get rid of that 90, the leftover for these two is 90. So alpha plus beta is equal to 90. And then we know that these triangles are similar, so let's set up some proportions here. So this says P over R. Let me, I'm going to get rid of the highlights on these angles. So let me highlight these sides. So we've got P over R. So now we want to do a similar thing over here. So what side goes with P? So the side that goes with P is C. And then the side that goes with R is B. So kind of highlighting those similar sides. And why don't I just get this third side labeled a different color while I'm at it? All right, so P over R. So we're going orange over blue. So we got to go orange over blue here. So C over B. Next one, they do P over C. So they do orange over orange equals W over what? So orange over orange should equal green over green. So W over A. Then in triangle 1, the cosine of alpha equals what? So remember, cosine of an angle equals the adjacent over the hypotenuse. So adjacent to the alpha is W, and then the hypotenuse is P, so W over P. For triangle 2, okay, the adjacent to alpha is A, and the hypotenuse across from that 90 is C, so the cosine is small a over C. Next one, they want the sine. Remember that sine is equal to opposite over hypotenuse. So now if we want sine of alpha, opposite of the alpha is the R, hypotenuse is still the P. So sine is going to be R over P. For triangle 2, opposite of alpha is B, and then the hypotenuse is C. So sine is going to be B over C. And then tangent. So remember, tangent is equal to opposite over adjacent. So we're still looking at alpha, so we can still use these measurements. Okay, so opposite is R over adjacent is W. For triangle 2, opposite is B, adjacent is A. Number 6, select all true equations. So cosine of 37 equals sine of 53. This is true because if these are, if these total 90, so 37 plus 53 equals 90, then the sine and cosine of them are the same. Okay, and you can think about that because if you had a 37-degree angle here and 53 here, and you had the sides labeled, okay, X, Y, Z, the cosine is going to be the adjacent. So cosine of this is adjacent X over hypotenuse Z. And then if you do the sine of 53, sine is opposite X over hypotenuse Z, they're the same. Okay, so as long as these two add to 90 and then you've got a sine and a cosine, true. That is not true of tangent. Okay, the tangent of those two angles would not be the same. The tangent of the 37 in this one would be y over x, and the tangent of the 53 would be x over y, not the same. You have a sine and a cosine here again, And then you've got 37 and 53, which total 90, so this one is true. The sine of two different angles, not going to be equal to each other. And then the cosine of theta with the sine of 90 minus theta. This would be true because theta plus 90 minus theta, well, the thetas are going to cancel out, and that's going to equal 90. So these are complementary angles, one sine, one cosine. Number 7, find the measure of the missing angles and sides. So let's find the length of AD to the nearest tenth. So when we look here, we've already got two sides labeled. We're just looking for the third one. So this is going to be a Pythagorean theorem here. So x is the hypotenuse, so x squared equals 10 squared plus 3 squared. So x squared equals 100 plus 9. So x squared equals 109. And then we'll just square root both sides. So undoing a squared is by square rooting. So square root of 109 gives us 10.4 to the nearest tenth. So we know that this side length is 10.4. Now we want to find the measures of these angles. So this is going to be by using inverse trig. So we want to label the sides. So you can pick either angle to solve for first. It doesn't matter. I'm going to solve for alpha. So I'm going to circle it, and I'm going to label these sides. So this 10 is the opposite side, and then the 3 is the adjacent side. So if I look at SOHCAHTOA, which one has the O and the A? That's going to be this tangent. So I'm going to set up a tangent function. So alpha is going to equal the tan inverse, since we're looking for the angle. Okay, so tan inverse of the opposite side. So opposite of alpha is 10 over the adjacent side, which is 3. So then you're just going to type that into your calculator. So do the tan inverse of 10 divided by 3. And you get to the nearest degree, 73 degrees. And then you can certainly set up another trig function here. But we also know that alpha and beta total 90 together. So we can do 90 minus 73. And we would get the measure of beta, which would be 17 degrees. If you wanted to set up another trig function for that, you certainly could. Then you'd be looking at beta. 3 would now be the opposite side. 10 would be the adjacent. So you'd have the tan inverse of 3 over 10. And then that would give you 17 degrees as well.